Okay, let's look at an example. I'm going to do example 4.4 in the textbook. Now, there's this ridge body right here, and the dimensions are given. It's subject to two forces. Okay, F1 and F2 are applied at point A, this corner, and point B at the end of this metal bar. You're asked to calculate the combined moment, okay, created by these two forces. So, by definition, moment, okay, about a point, any point, point O, goes R cross F. So this F1 will create a moment about point O, and let's call it MO1, and R, let's call it R1. Same thing for F2. About point O will give you a moment of 2. Okay? So the sum of these moments is the total moment. Okay? Total moment, the combined moment, simply equals to the sum of all the moments. Okay? So let's call it resultant. Okay? Resultant about O. Okay, so it's simply the sum of all the moments about point O. In this case, we have two terms, right? So, which is moment 1 plus moment O of 2. Okay, so which means that you need to figure out what is R1, what is R2. F1 and F2 are given. Okay, so let's write down the expression for R1. So R1 is measured from point O, okay, the point where you take moment about, to the point where F1 is being applied, so which is point A right here. So this is exactly R1 right here. Okay. So just to get a coordinate, so R1 is, well, it has 0x, 0z, and 5 feet, in the I direction. So it's simply 0I plus 5J plus 0K. R2 is measured from point O to B. So something like this. Okay? So knowing the coordinate, you can figure it out very easily. Piece of cake, right? So in the X direction, which is, well, this right here, so 4 feet I, positive, and then J in the Y direction, same thing, it's 5J, and then K, we're going downward, so negative 2 feet. Okay. So knowing these two, knowing the force vectors, you can just carry out the cross product. So you can do one at a time. So m dot, the moment about O for the first force equals to this guy right here. So exactly I, J, K, and then R1, which is this, so 0, 5, 0. And then F1, which is this, negative 60, positive 40, positive 20. So, just go through the calculation using whatever I laid out in the previous video, and just calculate it. And whatever it is, okay, so it's something I plus something J plus something K. Do the same for MO2. Okay, I, J, K, so 4, 5, negative 2, 80, 40, negative 30. Alright, so calculation. And then just sum both I terms, both J terms, both K terms. So the resultant, the total moment about point O. Alright, so I'm not going to do extra calculation here. Just copy down the result from the textbook. Okay, so positive 30, negative 40, plus 60. Okay. Now, an exam situation, a quiz exam situation, you're expected to show me all details, right? How you got all the IJK, and then do the sum. All right. So if you look at the textbook, also, there's a graph that shows this vector right here. Right. So vector, I'm going to draw it here, so it kind of points in this direction, right? So this is your resultant moment. Okay. So knowing the I, J, and K, well, this is a vector, just any vector, right? So like in chapter 2, when we talk about vectors in the Cartesian space, you can actually figure out the directional cosine, or rather the angles between this vector and each of the principal axes, right? So x, y, and z, right? So x would be alpha, right, beta, and gamma. Okay, so refer back to your notes, right? You can figure out alpha, or cosine of alpha, right, equals to the component, okay, which is this right here, which is 30, which is why I'm just going to write a symbol. So mx divided by the magnitude of this vector, okay, this moment, right? So if you do a quick calculation, the magnitude of this right here, this square plus this square plus this square, take square root, it's roughly equal to 78.1, and the unit is pound feet, okay, or foot pound. Alright, so cosine alpha is this, right, which is 30 divided by 78.1, so alpha roughly equals to 67.4 degrees. Alright, so it's this right here. Alright, you can do the same for beta and gamma.